Okay, we're going to try to do this without a net. Where is it? Is it focusing? Is it going to focus? This is the analog clock. This battery up here is the digital clock. Real-time clock, RTC. And we have a Arduino Nano running the program. I've got a BME 280 temperature module, but I don't have it running in this test right now because we're just going to talk about the clock. And I'm having trouble getting it focusing on, but I think it's viewable here. Okay, the point about the clock is, and the next trick is looking at the code. Okay, that was showing the clock. And the interesting thing about it, I'm going to upload this different program here right now. You can see it blasting away there, uploading. The interesting thing about the code is, you see right here, we've got the X assigned using a cosine and the Y using sine. I don't know why my went out of, there we go. Okay, I know this is pretty ugly, but let's see, down here, here's the actual code that displays the line, that draws a line. It oh, that's drawing the mark. Anyway, yeah, here it is. This is the code that draws the line. Everything is set from the center. And this is what was getting me. I was looking at the sine and cosine functions. Of course, this is assuming that it's a unit circle and it's working off of the radius being 1, and everything revolves around that, which that's no pun intended. And what we have here is a plot using, and in the calculation, the original author, let's see who I stole it from, Rinky Dink Electronics. That's me. I stole the code from Rinky Dink. I'm not Rinky Dink. He wrote this code for using a different library, and I didn't use his library. I used the Adafruit library, and it uses different functions. It uses similar functions, but just enough different that I had to make some modifications, like the color of the line to be drawn. I think that was really the only modification, and of course the name of the function I was running. Let's see, let's go back here, and we're talking about the cosine function. First, he multiplies it times 6. Well, not first. First is we get seconds from the clock, from the RTC, real-time clock. We get the time, then we get the seconds, and we put the seconds in here. And he multiplies it times 6. And you can see here on the chart, when he multiplies it times 6, it gives us the intervals. It will make 180 degrees. 30 seconds is 180 degrees. And 60 seconds will be 360 degrees. I didn't go that far with my fancy little chart here. But then he adds 270 degrees to it to bump it around. I found if I take that 270 off, that it starts in a little bit different place. And plotting was interesting. I say it was interesting. Let's go back to the other view. This is, for all practical purposes, a -1, which would be down here at the bottom. And it plots all the way around to a +1, which I found that confusing because it's going the correct way as you would on a unit circle, but on the actual clock, oh, I've got this one slowed down so it only moves every 5 seconds. But on the actual clock, it does go clockwise. On the unit circle, you run counterclockwise. But on the actual clock here, it runs clockwise. See if I can get that to focus on it. Okay, so you can see it down there. And we're coming up on a 180, and it's got a 1, a Y value of 1, so you can tell once you get to watching it, it's kind of upside down. And here this one is, it's a -10, so that value is correct. Except that was 270 degrees, wasn't it? And 270 belongs down here in the bottom. So you can see the whole shift between the way the display utilizes it. The display doesn't go counterclockwise, it goes clockwise. The values are all set off the center, and what am I trying to say? The XY coordinates where each pixel lies has no relation whatsoever to a unit circle. It all starts up there in the upper left-hand corner. It's 0, 0, and at the far right-hand bottom corner, it would be, what would it be, 168, 64? 128, 64. I forgot, yeah, I think it's 128, 64. This is one, good grief. Yeah, 128, 64. Now I'm lost in thought. So we've got there -1 and 0. So it's got the Y at a -1 when it's up at the very top. And here we go, we're rounding around to where we have 90 seconds. And we've got a 1 and 0, which is curious. So you see the way it corresponds to the unit circle and the way the time goes. So I'm not quite sure I've got it 100% understood, but it's pretty interesting. I was just fascinated with it, the trigonometry behind it, and like I said, of course I didn't write it, but I found it from somebody else and the way they did it. I thought it was quite interesting. You never write your own code. Everybody else has already done it, so it's easy to find these brilliant people and use their code, which that's the reason they put it out there, is for you to use it. So anyway, how's that excitement? Trigonometry in action. All right, that's all for now. No, it's not all for now. Come on.